Hello guys, welcome back to Mathematics Made Easy Volume 3 Part 2. Here we'll be learning logarithmic equation and as well as unknown logarithm from given values. So the next tutorial we are going to consider the use of logarithm table. So let's start with unknown logarithms from given values. Unknown logarithms are found by expressing them in terms of the given logarithm in accordance with the logarithm rules. For example, if you are given that log 2 is equal to 0.313010 and log 3 to be equal to 0.4771, and you have to find the values of, let's say, log 6. So this is the unknown logarithm. Now you'll be asked to find the unknown logarithm from the given logarithms. So these are the given logarithms. You use the given logarithms to solve for the unknown logarithms. And how can you do that? You express them in terms of this given logarithm. And the only way you can express them is to apply your logarithm rules, in which we have learned in the previous volume. So let's consider log 6 now. Let's express log 6 in terms of the given logarithm. Log 6 can be expressed as what? 2 times 3. So we express log 6 to be log 2 times 3. And don't forget, from the rules of logarithm, whenever you are adding two logarithms together, you multiply the numbers. So you can see that we can still express this one in terms of that rule, changing into what? Addition law. So this one can simply give us log 2 plus log 3. I believe we can see that now. And substitute the given values to it. And that is how you can get the unknown logarithm. So what's log 2 from the given value? 0.3010 plus what's log 3? 0.4771. I believe we can see that now. And we add. When we should add this one together, we'll be having 0.7781. I believe we can see that now. So for instance, if I given, let's say, log 15, you can express 15 in terms of the given value. How? You know that log 15 is what? You can say it's log 3 times 5. So 3 times 5 is 15. But if you check this problem now, realize that 5 is not part of the given logarithms. How do you go by 5? You find a means in which you can express 5 to be of the given logarithm. And how? We know that 10 divided by 2 is 5. And we all know that log 10 base 10 is always 1. So let's introduce 10 divided by 2. So the average ought to be what? Log 3 times 10 divided by 2. I believe you can see that now. And how do you go by that? Let's separate. So this one will give us what? Log 3. I believe you can see that now. M plus log 10. And division, don't forget that is subtraction, minus log 2. Therefore, log 15 will be equal to, so what's log 3? 0.4771. Then, see this, you should know it's a common logarithm. So log 10 base 10 is 1. Then minus log 2, 0.3010. So if you should add that together, you are going to get 1.1761. Let's consider another example. For instance, if I have to evaluate log 0.225 base 10, given that log 3 is equal to 0.477 and log 5 is equal to 0.699. So we have to evaluate this now. We have to evaluate log 0.225 from using the given logarithms. Now, how do you solve this? You first change the decimal number to fraction, and the easiest way to do that is just change it to express in terms of power of 10 to be easier for you. So let's express this one in terms of power of 10. So this one is going to give us log, that will be 1, 2, 3 now. So that will be 225 times 10 raised to the power what? Minus 3. We have added forward, so that will be negative. And you can see clearly we are having 225 times 10 raised to the power minus 3. So from the given logarithm, we are seeing 3 and 5, and you are seeing 225 there. No, you should have 225, you should expect 225 to become something like 25 times 9. Because 25 times 9 is going to give us 225. I believe you can see that now. Then times 10 raised to the power minus 3. So from here you can separate and simplify for that. Since you can express 25 as the power of 5 and you can express 9 as the power of 3. So it's very easy to solve. So let's separate. We'll be having log 25 plus log 9. Multiplication will add from that logarithm use. Then plus log 10 raised to the power minus 3. So we can simplify for that by condensing the large numbers. So we're having log 25 will become 5 raised to the power 2. And 9 will become 3 raised to the power 2 plus log 10 raised to the power minus 3. I believe you can see that now. So apply that law that says power, we multiply the whole logarithm. So power will now be, it will become 2 log 5 plus 2 log 3. Then plus times minus, there will be minus 3. Then log 10. Now put in the given values. What is log 5? So that will be 2 into log 5 is 0.699 plus log 3 is 0.477. Then minus 3. Remember, this is common logarithm. So log 10 base 10 is 1. And if we should simplify that, we are going to get minus 0.648. Let's consider another example. If we are given, let's say, 10 raised to the power n is equal to 0.63 and log 63 base 10 is equal to 1.8, and you have to find the value of n. It's very simple. So I'm given that what? Log 63 base 10 is equal to 1.8 and 10 raised to the power n is 0.63. So to find the value of our n here, you simply take the log of both sides. So let's take the log of both sides. That will be log 10 raised to the power n equals log 0.63. And you can see that from that log power multiply the logarithm. So they're having n log 10 base 10 equals here now. You now express this one in terms of the given logarithm. So the only way you can express this one is to change this one to what? To fraction or as power of 10. So as power of 10 will be 2 terms. That 10 raised to the power minus 2. So they're having this to be log 63 times 10 raised to the power 1 2 now. That will be minus 2. And imagine forward is negative. That will be minus 2. And from here you can see log 10 base 10. Since this is common logarithm, even though there is no 10, there should know it's base 10. It's common logarithm. So log 10 base 10 is 1. So we're having n times 1 equals, apply your logarithm rule here. Multiplication will change to addition. Don't forget that. That will be log 63 plus log 10 raised to the power minus 2. I mean, you can see that. And what was n times 1? N equals log 63. Power here will change to, we multiply the logarithm now. So they're having minus 2 log 10 base 10. I mean, you can see that. So let's substitute the given values. Since log 63 base 10 is 1.8, substitute, that will be 1.8 minus 2. What was log 10 base 10? 1. And that will be n equals to 1.8 minus 2 times 1 is 2. And what was 1.8 minus 2? That will be minus 0.2. So that will be minus 0.20. And that is the answer. Let us consider another example. If log 3 base 10 is 0.4771 and 10 raised to the power x is 0.3, and you have to find the value of s. Still similar to that one, very simple. You will be given that log 3 base 10 is 0.4771 and 10 raised to power x is what? 0.3. So to find the value of s from the given value is very simple. Simply take the log of both sides. So that will be log 10 raised to power x equals log 0.3. Don't forget, power will multiply the logarithm. That will be s log 10 base 10. You can put it. You can express it b in form of the given logarithm, and I'll change to fraction. All expressed as power of 10. That will be 1 times 10 raised to power minus 1. That will be log 3 times 10 raised to power minus 1. Can you see that now? Base 10. And what's log 10 base 10? 1. That will be s times 1. And change that one back to the logarithm addition. Change to addition. That will be log 3 plus log 10 raised to power minus 1 base 10. Can you see that now? So we are having s times 1 x equals log 3 base 10. Power you change to multiply the logarithm now. So we are having minus log 10 base 10. So let's substitute the given value. What's the given value? Log 3 base 10, which is 0.4771. Then minus. We all know that log 10 base 10 is 1. So what's 0.4771 minus 1? That will be minus 0.5229. Simple as that. So that's all about unknown logarithms from given values. So whenever you are given unknown logarithms from given values, simply express the logarithm in terms of the given values. As simple as that. So let's move to logarithmic equations. So let us now consider logarithmic equation. Now, what do we call logarithmic equation? This is an equation. This is an equation that involves the logarithm of an expression containing a variable. And we know that then I said logarithm of a number to a particular base is the power to which the base must be raised to obtain the number. We call that if log n base a is equal to s, then a is power of s, a is power of the result is equal to the number. And that's how I define logarithm. The logarithm of a number to a particular base is the power to which the base must be raised to obtain the number. That is, logarithm of n now to base a, which is x, is what? Is the power to which the base must be raised. That is, this is the power to which the base must be raised to obtain what? To obtain the number. So whenever I come across something like this, you know, n is simply what? The base power the result. Can you see? N base power the result. So it will be very, very useful while solving problems under logarithmic equation. And you must also know the logarithm rules. The only difference there is the equal to sign, which make it to be an equation. Therefore, let's consider some examples, starting from the basic one. So examples now of logarithmic equations. Therefore, example, if let's say log 5s plus tv base tv is equal to 1, and you have to find s. It's very simple. Once you know what you are doing, you will be given log 5s plus tv base tv equals 1. Simply apply the basic knowledge that the number is always equal to the base power the result. Can you see that? Very simple. Just from the derivation of logarithm, you can simplify this. So you can simply say 5s plus tv is equal to what? 3 raised to power 1. No waste of time taking log of both sides. So with that knowledge, go straight. And what's 3 raised to power 1? 3. So we're having 5x plus tv equals 3. And how do you find 5s here? We collect like time now. So we're having 5s to be what? 3. That one will go up minus 3. And 5x to be what? 0. Happy? If I go side by 5, we're having s to be what? 0 divided by 5. And what 0 divided by 5? 0. So s is 0 here. Example 2. If we are given, let's say log s plus 3 into s minus 3 base 4 equals to 2, and you have to find s. So, very simple. Oh, this one will simply give you like that. We are given log s plus 3 into s minus 3 base 4 equals 2. And that shows that the number which is s plus 3, s minus 3 is going to be the what? The base raised to the power the result. Can you see that now? Just be using that basic principle. And to solve this, seeing this expression, you can expand. But if you are the one that know what you are doing, then this one is simply difference of two squares. Yes, difference of two squares. So it's easy to solve. You can simply say s squared minus 3 squared is still going to give you this. Then equals to what's 4 squared? 16. So we're having s squared minus what's 3 squared? 9 equals 16. Then out to the other side, I'll be having s squared to be what? 16, then plus 9. And what 16 plus 9? You can see is 25. Yes, 25. So what we do, take the square root of both sides. So we're having s squared, take the square root equals square root of 25 to be plus or minus. So square, we cancel square root here. We're having s to be what? Square root of 25 is 5. That will be plus or minus 5. So s is plus or minus 5. So if you are given, let's say 1 over 2 log s base 10 equals 1. Very, very simple and straightforward. There's nothing difficult here. Because this one is having number at the back of the log, Abi. If you change it back to the power, so you know that the power is the one that is always multiplying the log. So this one power back to the power, so we're having log s is power half, Abi, base 10 equals 1. So very simple, and apply that law. Number still be what? Base power. What is it, Abi? And how do you solve this? How do you simplify this? Multiply the power, the unknown, power of the unknown by the multiplicative inverse. So the multiplicative inverse of 1 over 2 is 2. Or you change this one to square root, then square both sides. It's still the same thing. We're having half multiplied by the inverse of the power, which is 2. It affects both sides. Abi? You can see school, you can see 2. So be left with x equals 1 times 2 is 2. That will be 10 raised power 2. Now what's 10 raised power 2? 100. 10 times 10, which is 100. Another example. If I given log 3s minus 4 base 10 minus log 2 base 10 equals 1. Here now, what we apply here? Subtraction law now. Now listen to division. Easy. So we just be having log 3s minus 4 divided by what? 2. Since I have the same base equals 1. And apply that law. 3s minus 4 divided by 2 will give us what? 10 raised power 1. So single fraction we can put over 1. Now what's 10 raised power 1 still 10. So cross multiply there. When we affect this, that will be 1 into 3s minus 4 equals what? 2 times 10. Happy? And once you open the bracket, you still give it that thing back. 1 times 3 is 3s, 1 times minus 4. We're having 3s minus 4 equals 2 times 10, 20. And you collect like 10. We're having 3s to be what? 20 then plus 4. And what's 20 plus 4? 24. Don't forget when crossing, sign will always change. And divide both side by 3 here. So we're having 3s divided by 3 equals 24 divided by 3. 3 divided by 3, and s should be equal to 3 24, 8. So as simple as that. Log s base 3 all squared minus 6 log s base 3 plus 9 equals 0. And you have to find the values of s. In this case, we are given log s base 3 is power 2 minus 6 log s base 3 plus 9 equals 0. Now we can see that the power here is not only for the s, it's for the logarithm. So don't change this one to s. This one is different from log s power 2 base 3 is different from this. So you can't just say 2 because of the bracket. So you have to be very careful while solving questions under logarithm. Now how do you go by this? It's very simple. You realize that since this one is having squared, and we are still having this similar logarithm in another term from the given equation. So let log s base 3 be any letter. Let's say be a. Whenever you see log s base 3 represented with a, so from here now we can see that this one will become a carrying power of 2 minus 6a then plus 9 equals to 0. Because this is the quadratic equation. Two factors that you multiply, that will give you 9, and that you add, that will give you minus 6. And what is that? Minus 3 times minus 3 plus 9. Minus 3 minus 3 minus 6. So the answer is just minus 3 into minus 3 equals 0. Abi? And therefore you say a is what? A is 3. You can say it's equal to 3 twice. So if you know that a is 3, now you put it back s. We call that what? Log s base 3 is equal to a, just as it is written here. We are looking for s, not a. That will become log s base 3 equals, what's our a now? 3. And apply that law that says number will be what? Base raised to power. Just like that. Now what's s raised to power 3? 27. And your s is simply equals to 27. I believe you can see that. Simple as that. Log 3 base s plus log s base 3 equals to 0.5. You can see that the logarithm are not of the same base. You have to express them to be of the same base. And how? Don't forget from the knowledge of change of base from your logarithm rule. So let's change one of it to be in form of the other. So we can say this one is 1 over, don't forget it, the base will change like that. That will be log s base 3, then plus log s base 3 equals, I change this decimal number to fraction. And what's 2.5 to fraction? That will be 25 over 10, which you can reduce to its lowest term. So let's reduce that to its lowest term first. So 5 in 25 is 5, and 5 in 10 is 2. So we're having 5 divided by 2. I mean, you can see that now. So the best way we can solve this to make it easier for you is to let log s base 3 be any letter. So representing log s base 3 to be b, you can simply have 1 over b plus b equals 5 over 2. So same fraction, put over 1 here. And all what you need to do here is to multiply through by the LCM. LCM of b1 and 2 is 2b. So multiply through by 2b. So we're having 2b times 1 over b plus 2b times b over 1 equals 2b times 5 over 2. So b will divide b. It will be left with 2 here, 2 times 1, 2 plus 2b times b will become 2b squared equals 2 will divide 2 here. B times 5 will become 5b. And we arrange. This is a quadratic question. So we are having 2b squared then minus 5b plus 2 equals 0. So let's use factorization method. This will multiply the cost and that will be 4. So number I can multiply together, I will give you 4 and add, I will give you minus 5. So that should be minus 4 times minus 1. So minus 4 times minus 1 is plus 4 and minus 4 minus 1 is minus 5. So we are having 2b squared minus 4b minus b plus 2 equals 0. And factorize by grouping. So we are having 2b squared minus 4b grouped minus into b minus 2 grouped equals to 0. And take out the common factor. The common factor here is 2b. So we are having 2b and we left with b only there minus 2 left there, abi? Into that will be minus 1 into b minus 2 equals 0. Since 1 is the only common factor there. So I was common again, b minus 2. I'll be left with 2b minus 1 equals 0. And therefore, we can see that b is equal to 2 here, or b is simply 1 over 2. And don't forget that we're not looking for b. What are we looking for? X. And from here, we can see that log s base 3 is our what? Is our b. And that shows that from there, you can say that log s base 3 is equal to 2, or log s base 3 equals 1 over 2. And apply that law, simply says number will be equal to this one, carry the power. So we're having 3 raised to power 2, or s is what? 3 raised to power half. And your s will simply be 9, or square root of 3. As simple as that. So the last example we are going to consider is the one that always involves simultaneous equations. You can see in any form, but I will use one as an example. So, if for example, if I to consider, let's say log s minus 5y plus 4 base 2 to be equal to 0, and log s plus 1 base 2 minus 1 to be equal to log y base 2. And here you have to find the values of x and y. It's very simple. Start with the first given equation. We are given log s minus 5y plus 4 base 2 to be equal to 0. Apply that law, that simply say x minus 5y plus 4, the number is equal to what? This one, this will be power of that. Abi? And what's 2 is power 0? Anything is power 0 is 1. So that having x minus 5y plus 4 equals to x power 0 is 1. You can rearrange to form simultaneous equation. So this will be the equation 1 there. So we're having x minus 5y equals 1 then minus 4. And x minus 5y will simply give us, what was 1 minus 4? That would be minus 3. So we can call this one equation 1. So consider the second equation. What is the second equation? Log x plus 1 base 2 minus 1 equals 2 log y base 2. So how do you simplify this? It's very, very simple. You know that the log of the numbers with that same number as the base is always 1. You can change the 1 here log 2 base 2. And that will simply be having log s plus 1 base 2 then minus log 2 base 2 equals, you can simply change this one back to the power. And that will be log y is power 2 base 2. So from here you can apply your subtraction law in which you divide the numbers. So we're having log s plus 1 divided by 2 base 2 equals what? Log y squared base 2. So since I have the same base, you can see the number will be the same. So that will give us s plus 1 divided by 2 to be equal to what? Y squared. Same fraction put over 1 and cross multiply. So we have 1 into s plus 1 equals 2 times y squared. If not to expand, that will be s plus 1 equals 2y squared. And we arrange. So we are having s minus 2y squared equals minus 1. And that will be equation 2. Now, since we are saying one of the unknown here to be a power of 2, you know, is a quadratic equation. So the best way you can solve this problem is to use substitution method. The substitution method from equation 1, you can see that s minus 5y equals minus 3. So you can make s the subject here. So x will be equal to, please say 5y then minus 3. You can call this one equation 3. Take this on the other side, become plus. Simply put equation 3 into 2. So anywhere we see s, we put in this value. So instead of x and now, we simply say 5y minus 3 then minus 2y squared equals minus 1. And let's arrange it to quadratic equation. So we're having minus 2y squared plus 5y minus 3, that one we call that plus 1 equals 0. Minus 2y squared plus 5y minus 2 equals 0. Minus 3 plus 1 is minus 2. Having this, you can multiply through by minus 1. So this one will become 2y minus 5y then plus 2 equals 0. And you can factorize. 2 times 2, 4. That will be minus 4 minus 1. That will give us minus 5. And minus 4 times minus 1 is plus 4. So put in the two factors. That will be 2y squared minus 4y then minus y plus 2. And factorize by grouping. So that will be 2y squared minus 4y then minus into y minus 2 equals 0. This negative is affected, don't forget. So let's group. 2y is common. Let's factorize. 2y is common into what will be left here now? Y minus the left with 2 here. And the common one is 1. So equals 0. Y minus 2 is common again, take it out. What will be left? 2y then minus 1 equals 0. As simple as that. So therefore, you can simply say y is 2 or y is minus 1, 1 divided by 2. If we solve that. So that's the value of our y. And let's solve for s. So from equation 3, you can see that s is simply 5y minus 3. That shows s may be 5 into 2. So let's put 2 minus 3. Or s may be 5 into 1 over 2 minus 3. So s will simply give us 2 times 5, 10 minus 3. That will be 7. Or here now, you can see this one will become 5 over 2 minus 3 over 1. And LCM there is 2. So 2 into is 1. 1 times 5, 5. 1 into 2, 2 times 3 is 6. That will be 5 minus 6, which should be what? Minus 1. So S is equal to 7 or minus 1 over 2. As simple as that. So Y is 2 or Y is this, and S is 7 or minus 1 over 2. And that is the solution to the logarithm given. So this come to the end of Mathematics Main Busy Volume 3 Part 2. Watch out for Part 3, where we'll be learning the use of logarithm table. Please don't forget to like, share, comment and subscribe. Thanks for watching.